You know
सर
some.
ईंट का चूरा जो होता है ना,
Huh?
शायद। सर ईंट का चूरा, रेड कलर का।
Good. Uh, it is red in color. It's red in color. You have that material. If you combine it with lime, it's actually a sandstone, which had more. It had more composition of sandstone, and at times the bricks भी उसी की बनी होती थी, and they would crush that, add some amount of lime, and then add the water, and then compact it at the place of its casting. So a very good material which had a very good cementitious properties. Now coming back to cement, what uh, is the cement that we have present as of today? जो हमारा मॉडर्न सीमेंट आज की डेट में है, इस इसकी शुरुआत किसने की? दैट वाज जॉन स्मेटन, द गाय विद द नेम ऑफ John Smeaton, and this was year 1756. He laid down the foundation for construction of the modern cement, the first foundation, and he constructed a lighthouse in Eddystone. Was a place, Eddystone was a place where he constructed the lighthouse. This lighthouse, a lighthouse which is constructed at the end of near a port or near a harbor. So that was constructed by a material which had a predominant composition of pozzolana material, pozzolanic material. It had a pozzolanic material, then it had limestone. Now he added some amount of clay material in it. Until that time, until year 1756, it was felt that if you add clay into this whole mixture, it's not that good. Although there is some amount of consideration for adding the clay from the tiles here, which are actually the tiles are made of from clay. But here the clay was added as clay itself. So the first time it was considered as an ingredient which was impure and it will not give strength. Clay does not give you strength. But Smeaton did that. उसने क्या किया? उसने clay भी इसके साथ पोज़ोलाना, इससे पहले आप देख रहे हो, pozzolanic material was volcanic ash, lime was added, clay tiles were added, and water was added. Now John Smeaton added pozzolanic material, which is fly ash or volcanic ash, then limestone, same like that, but he also added a clay material, and then water is always added to bind, to set in the chemical reactions. So this combination of limestone with clay material and water, this one, limestone, clay material, and water, they together formed the hydraulic lime. This is also known as hydraulic lime. Now this material is formed once the limestone, the clay material, and the water were combined. So it was called as a hydraulic lime because it had a unique property of combination now with water. The limestone and the clay had a property of combining with the water. So it was known as hydraulic lime. And then if you know, I have to know how did it combine. It was actually the lime and the clay were burned together. What he did, lime and clay, इनको अलग मिलाया. कैसे? पहले इनको, he burned them together. These two were burned together. Once they were burned together, something was formed, some solid material was formed, and then it was combined with water, and then with the pozzolanic material, and what was obtained was a cement. this combined, the burned material easily combined with water, and it obtained the hydraulic lime, and then it was combined with pozzolanic material to give an extra strength. So this was done by John's method. The Roman cement. Who is this? Who is this? So Roman cement. Now, what is a Roman cement? This was developed by James Parker. It's a modern Roman cement. Roman cement, I just told you what it was combined of, but James Parker, what he did, he used the same technology which was used by the Romans long back, 2000 years back. He calcined nodules of argillaceous limestone. Now, there are 4 terms involved here. One is calcined. Calcined, you know, just I told you, the calcium component that is present in gypsum as well, the calcium chloride. Nodules, so they were in the form of balls. How were the balls obtained? It was a combination of argillaceous. Now, argillaceous is actually, if you want to say in technical terms, clay. This is clay actually. This is clay. Clay has got most of the component of the clay is aluminates, and it is argillaceous in combination with limestone. So aluminates, you also call that as argillaceous. Then it is combined with limestone, which has got a predominant component of then silicates and calcium again. So they were burned together, like here, limestone and clay. So limestone and clay is burnt here together. The nodules are formed, and the nodules are then calcined with gypsum. So this was then the Roman cement was developed by the James Parker in 1824. This is year 1824. Then you had one more type of cement, which has actually laid down what we are using today. Joseph Aston in 1824, again, what he did, he developed what is today known as the Portland cement. So the modern Portland cement, when you go to the market, जब आप एक सीमेंट का बैग आज की डेट में लेते हो, आपको वहां पर उसमें लिखा होता है ओपीसी, पोर्टलैंड सीमेंट, ऐसे ही लिखा होगा ओपीसी इज ऑर्डिनरी पोर्टलैंड सीमेंट, ऐसे लिखा होगा ओपीसी और लिखा होगा पोर्टलैंड सीमेंट. So this was developed by Joseph Aston. Now it is the combination of, again, the same materials but in a different form. He used finely divided clay again, जैसे ऊपर है argillaceous material which gives the aluminates. Then the hard limestone was used. Now, when these two were combined, what was formed? How were they combined? Clay and limestone, they are combined in a furnace, taken to a particular temperature of heating, and there the cement production happens. This laid the foundation of the modern cement. So the hard limestone and the finely divided clay was used by him to obtain the Portland cement. Now, in 1845, after this, Isaac Johnson, what he did, he combined the same thing, the clay, again finely divided, plus chalk, So now in place of limestone, he is using the chalk, clay and chalk rather than limestone. And what was done actually, this was allowed to reach a process in the furnace till clinkering. Till clinkering has happened. Now, what is clinkering? I'll explain to you as I'll teach you the methodology of how cement is produced. So, what is Portland? Why do we call it as Portland? It is actually a Portland stone. जहां से ये limestone आता है, the hard limestone here that I'm talking about. तो वो एक पोर्टलैंड जगह है, तो वहां से एक पोर्टलैंड स्टोन मिलता है, and this place is somewhere near Dorset, and it is actually a limestone rock. And you can check which country this place Dorset belongs to. I can't recall. So it is a place near Dorset where this Portland stone was directly obtained, and the cement material produced by Isaac Johnson after Joseph Aston. Now this had a much better cementitious properties. So it actually comes down to इसकी property जो है, it comes down to the actual material आप basic material कौन सा लेते हो? What is the basic material that you are taking? While now, what is the basic material that you are taking now? Yes, anyone? Just जो हमने अभी पढ़ा. Adnan 76. What are the basic materials we are taking in construction of cement construction में कौन से materials हमने use किए? जो समय एस्क्रिन ने कौन? हाँ जी. हाँ ना 76.
यस सर, हम लाइम मटेरियल्स यूज करते हैं और उसी के साथ साथ ही हम करते हैं सर जो हमारे एल्यूमिनेट्स होते हैं जो हमें मिलते हैं सर वही यूज करते हैं. कैल्साइनाइट जिप्सम जैसे इजिप्शियंस ने यूज किए थे, सीमेंटेशियस मटेरियल करते हैं यूज, उसके लिए ग्रीक्स ने किए थे कैल्साइट लाइमस्टोन सर, ऐसे ही मटेरियल्स हम यूज करते हैं. और अभी के जो भी हम करते हैं सर वो पोर्टलैंड जो ऑर्डिनरी पोर्टलैंड सीमेंट है वो यूज करते हैं.
Now the ordinary Portland cement उसके दो मेन कंपोनेंट्स है, एक है limestone and दूसरा है clay. दो मेन कंपोनेंट्स. So as of today we are using clay and limestone in construction of cement. Now these two materials are available throughout the world, so cement production can happen throughout the world. So in every country of the world, every country, 200 कितने countries है अभी, 4 है, कितने हैं वो सारे छोटे छोटे कंट्रीज को मिला के 210 भी बन जाए, विच आर द पार्ट ऑफ दिस. सो हर एक कंट्री में सीमेंट प्लांट अभी की डेट में है और हर एक रीजन में सीमेंट प्लांट है. सो इट्स वेरी इजी टू कंस्ट्रक्ट अ सीमेंट फैक्ट्री बिकॉज द मटेरियल्स आर वाइडली अवेलेबल थ्रू आउट द वर्ल्ड. Clay is available everywhere, limestone is available everywhere. Very basic problem, that is the production of gases while the cement is produced in the factories. Now when they are combined in furnaces. Clay and limestone, they are together combined in a furnace. एक furnace में डाला जाता है. You can I'll check with certain videos if I have, I'll send that to you, how the production that happens in the factories, how that's done. Now furnace में temperature, it has to be taken to a temperature of 1450 degrees Celsius for the two materials to combine together. Clay and limestone to combine together, it requires a temperature of 1450 degrees Celsius. कितना? 1450 degrees Celsius. And to reach to that temperature, you need a furnace that has to be operated by only two mechanisms of energy that can be used in उस टेम्परेचर तक पहुंचाने के लिए, या तो ऑयल या तो कोल. इलेक्ट्रिसिटी पे अगर जो furnace है, it's very difficult to take a furnace operated on electricity. It will consume a huge amount of electricity if we operate an electrically operated furnace, which is a clean energy furnace. Now, when coal is burnt, it produces a lot of gases, like carbon dioxide is the important gas. Now, in clean energy program, if we look at that, then cement production is itself generating a lot of carbon dioxide into the atmosphere. So now I will tell you how much does it produce. It produces around, there are two processes. One is a wet process of manufacture of cement, and another is dry process of manufacture of cement. In wet process, more energy is involved in its construction, in its manufacture. So you require around 120 kg of coal for every 1 ton, that's 1000 kg of cement. In India, we have one cement bag of how many kgs? Can anybody tell me? एक cement bag kg का होता है?
50.
Who is saying this?
50.
What's your roll number?
82.
82. 50 kg is right. In India, we have 50 kg, one cement bag. In UK, from where cement production actually started in India, the modern production, once a colonization was done, so उस time पे when the English government was here, they started the cement factories in India as well. So they also have 50 kg cement bags. Even as of today, the same thing is done there. 50 kg cement bag there and 50 kg cement bag here. Now, USA has got one cement bag of probably some 42 kg, I remember. Ek cement bag, it's 42.6 kg. Ek cement bag, 42.6 kg, because they calculate it in pounds actually. So one cement bag is 42.6 kg there. In India, we have 50 kg. And in most of the subcontinent countries, you will have 50 kg cement bag. But in certain Russian countries and others, they used to even 25 kg cement bags. Now, 1000 kg of cement means how many cement bags? Yes? Yes, anyone?
20.
20 bags. So 20 bags of cement बनाने के लिए 120 kg कोयला चाहिए. For in a wet process. Dry process में उससे कम चाहिए होता है, 80 kg चाहिए होता है. In dry process, you require 80 kg for 20 bags of cement. I'm talking about when you are talking about the Indian bag, cement bag. This is in dry process. Now tell me, this 120 kg of coal would be around